Definite integrals. So definite integrals are when you do integration, but they are bounded by 2 points. When I say bounded by 2 points, for example, if we have a graph here of an integral, the 2 points, A and B, what we mean is if we've got point A here and point B here, we're looking for the area under the curve between these 2 points. Let's give it a go with this first question. We've got the integral of 3x minus 8 with respect to x, bounded by the points 2 and 3. So we start the integration as normal. We integrate both parts. So we've got 3x and minus 8. Well, 3x integrates to 3x squared over 2. And minus 8 integrates to minus 8x. So we've done the integration now. And this is bounded between the points 3 and 2. If you're wondering where plus c is, I'll explain that in a moment. So as it's bounded by 3 and 2, what this means is all of this will substitute 3 in for x, and then we'll take away all of this when we substitute in 2. So firstly, I'm going to write it out in full. So we've got 3 over 2 lots of 3 squared minus 8 lots of 3. Minus, now we're substituting 2 into the expression, so we've got 3 over 2, 2 squared minus 8 lots of 2. If we simplify this down, simplifying it even more, we'll have, I'll carry it on up here, which that will equal minus 1/2. So the area under the curve of 3x minus 8, bounded by the points 3 and 2, is minus 1/2. So my question was, why do we not include c? Well, to try and keep this simple, if we had the function of x, so the integrated equation, it always includes plus c. So I'm just going to put the plus c next to it. Now that's bounded by the points a and b. If we substitute in these points, we'll have f of b plus c minus f of a plus c. Now if we take it out the brackets and make it nicer, we'll have f of b plus c minus f of a minus c, and then I'll just rearrange this a little bit. So we'll have f of b minus f of a plus c minus c. So if we look at this part here now, you can see that c and minus c cancel out. So because they cancel out, we don't tend to write c in the process. Second question, then there'll be some questions for yourself. We've got 4 cos 2x plus x to the 5th all over 4 with respect to x, bounded by the points 0 and 8. So we've got 2 parts, this part and this part. For this part, we've got 4 cos 2x. Let's look for cos kx in the table of derivatives, which is here. To go back, it becomes sine 2x, and then we're going to divide by 2, plus x to the 5th, we'll add 1 to 1/5, and we'll have x to the 6 over 5, divided by 6/5. I'm just going to write it 1 over 4, divided by 6/5, plus c. So we'll then be left with the equation plus c. And this is bounded by the points 8 and 0. So let's substitute in those values now. So we've got 2 sine of 2 lots of 8 plus 5 over 24 lots of 8 to the 6 over 5 minus 2 lots of sine of 2 lots of 0 plus 5 over 24 lots of 0 to the 6 over 5. Now this is quite a bit of a calculation to work out. So there's 2 ways you could do it. You could plug the whole lot into your calculator and work it out in one go at this point. Or if you prefer, you can calculate this bit and get an answer for that, and then calculate this bit and get an answer for that. Then do this bit, take away this bit. Me personally, I entered all this in one go. to get an answer of 1.950387644, but to 2 decimal places, this will be 1.95. Now, one really important note to remember is you must use radians. So calculate bounded points of integrals using radians, not degrees. 4 questions for you to try out. Pause the video and resume when you're ready to see the answers. If you want to see me work out these answers, there's a link at the end of this video and in the description below. At this point, there's a nice little trick you can do to make your life a little easier when integrating, and that's taking out a coefficient. And what I mean by this is if you have a common numerical factor across this equation, then you can take it out and put it outside of the integral. So for this, we've got 4 and 24. Now a common factor of both of these is 4. So if we take out the common factor of 4, we'll have 4 lots of the integral bounded between 3 and 5, lots of x to the 6 plus 6x squared dx. Now we can work this out the same as before, we'll just at the end multiply it by 4. So we've got x to the 6 and plus 6x squared, so x to the 6 becomes x to the 7 all over 7, plus 6x to the 3 all over 3, and we've got all this bounded by the points 5 and 3, but also it's all multiplied by 4, and just to tidy it up a bit, we've got 4 lots of x to the 7 over 7 plus 2x cubed, bounded by the points 5 and 3. I'm just going to move all this. So now we need to substitute in those points. So we'll have 4 lots of 5 to the 7 over 7 plus 2 lots of 5 cubed minus 3 to the 7 over 7 plus 2 lots of 3 cubed. Now as it's in a numerical form, we can enter all of this into our calculator in one go. So we'll have equals 44,177 and 1/7, or 44,177.14 to 2 decimal places. Last example before your turn questions, we've got 30 sin 3x and minus 10 over x. They've got a common factor of 10, so we're going to take out a factor of 10, so 10 multiplied by the integral bounded between the points 1 and 7, lots of 3 sine 3x minus 1 over x with respect to x. Working these two parts out now. Firstly, 3 sine 3x, I'm going to refer to this part here. So to go backwards, it's going to become minus cos 3x. Got the 3 there, and then it's going to be divided by 3 because we're dividing by this constant here. Because if we go forward, it's times by the constant. Seeing as we're going back, we have to divide by the constant. Minus 1 over x. So we've got 1 over x here, and that becomes ln x. So minus ln x. Then bounded by the points 7 and 1. And this is all multiplied by 10. We'll tidy this up just a little bit. And then that equals 10 lots of minus cos 3 times 7 minus ln 7 minus cos 3 times 1 minus ln 1. And then I'm just going to tidy it up for the calculator. Enter that into your calculator and you'll end up with minus 23.88173385, or rounded to 2 decimal places, minus 23.88. 3 questions for you to try now. Remember, take out the common coefficient of each question and then integrate as normal. Pause the video, resume when you're ready to see the answers. Here they are. If you want to see the answers to these worked out in detail, the link to the video of this is at the end of this video and in the description below. Thanks for watching, check out the next video, like, subscribe and support the channel. For now though, stay safe and healthy and I'll see you in the next video.